So good afternoon, Sir Engineer MR Catolico, and good afternoon to our viewers. Our report is all about free vibration, which is magandang topic na pag-aralan natin ngayon na makatulong sa ating future sa field natin. So let me introduce to you yung mga ka-groupmates ko, which is ako, si Peter Jan A. Galentes, Albert Kitong, Nil Tesnado, Aljan Carawana, Leonard, Roque, Darwin Malinlin, Irish Lou Martinez, Ann K. Silva, and Narold Lucia. So ako yung unang magpe-present ng aming PPT. So ito ang introduction ng ating report for today, which is our PPT presentation. So punta na tayo ngayon sa ating first slide, which is ating free vibration. So ano nga ba yung free vibration, no? Free vibration is a boundary element method for the analysis of free vibration in solid mechanics is developed using a non-standard boundary. So ano nga ba yung non-standard boundary, no? So yung non-standard boundary is constraints necessary for the solution of a boundary of value or problem. So ang meaning nito is mas nagagamit ito ang boundary is yung value of differential equation, which is the system of differential equation is to be solved. So napag-aralan naman natin na dati pa yung sa differential equation, sa integral. So medyo familiar na tayo doon. So ang free vibration daw is hindi lang siya bastang kung may isip natin na about solar energy. So meron din ditong solving talaga. So parang ganun yung meaning nun. So ano nga ba is to be solved in a domain whose boundary set in conditions, no? So may conditions siya, no? Hindi siya basta-basta pwedeng ma-solve ng basta-basta. So merong conditions. Is known all about. So ayun nga, so yung free vibration is di lang siya basta about sa mga solar energy. So pag-aaralan din natin dito yung speed, yung about mechanical nga, yung mechanics, ano nga ba yung may mga dito, may mga beams dito, strings and plates. So pag-aaralan natin dito 'yon. So next naman is yung next slide tayo, which is ayan. So free vibration ulit. So yung free vibration offers a great alternative or harnessing green energy has been receiving significant attention for the past few decades. So kung makikita naman natin sa illustration, no? So makikita natin dito, kung familiar tayo dun sa Ilocos, yung ating windmill, no, na nakapaggawa ng solar energy through wind. So ayun yung great example ng ating free vibration, no. So ayun, ano nga ba? So yung free vibration din, kung makikita natin sa illustration or yung picture na present natin ngayon dito sa ating harapan, is merong renewable energy. So yung mga renewable energy nga, ito yung yung may mga mas nakakatulong sa ating sa ating mundo. I mean, sa ating paligid, no? Na hindi maapektuhan yung mga forest natin, yung mga tubig natin. Kasi 'di ba, ang karaniwan ngayon na ginagamit is minsan 'di ba, ang nakikita natin sa mga poste-poste na lang ganun. So may mga sinisirang puno kasi doon, no? Na na mas nakakasira sa ating kapiligiran na na mas sana makakatulong para mas malinis yung ating air, no. So tapos ano nga ba yung green energy? So yung green energy comes from natural resources nga, such as the sun. So kung ang pinaka-familiar sa atin dito, no, kung pag sinabing solar energy such as the sun, so yung mga solar panel natin. So kung makikita natin guys sa mga natin sa RTU, meron dong tinayong solar panel, no, which is our solar energy, na ginagamit na ngayon sa CED building ata yun. Oo, tama, CED building. And then, alam ko meron din sa CAIT building. Di ko sure, pero nakakita ko ng solar energy sa CED building na ginawa ng ating school administration. So, ayun, mas makakatulong yun para mas makatipid tayo sa kuryente. Na hindi na tayo masyadong aasa pa sa Meralco, ganun. As makatipid din tayo sa, siyempre sa bayad. Kasi siyempre, yung LTU is free tuition. So, magbabayad ka lang pag bumagsak ka, ganun. So, malaking tulong din yun sa school para mas makatipid sa mga mas pangangailangan pa ng school natin. Tapos ano pa ba? Ano pa ba? Hindi lang siya solar, no. Pwede ring sa water, no. Ang example din nito is yung sa Laguna, Laguna Falls, Pagsanhan Falls, ayun. So ginagamit din yung falls doon as part of green energy natin kasi yung pagbagsak ng falls na nakakapaggawa siya ng energy which is natatransform siya into electricity. So yung pagbagsak ng alon which is yung sobrang lakas ng force ng pagbagsak ng alon sa tubig. So sobrang lakas doon nakapag-form tayo ng energy na which is na-transform nila ngayon na renewable energy na pwedeng makapaggawa ng energy sa Laguna. So pwede din siyang so ayun nga mas makatipid din sila sa paggamit ng energy and then din siya green energy which is makakatulong sa natin sa kapaligiran. So ayun medyo alam niyo na yung about sa pre-vibration na mas ginagamit din siya about sa renewable energy, no? So about energy din. So next slide. So yun, next slide is vibration engineering, no? Kung makikita nyo, vibration engineering, explain natin, no? Help our society to improve solar energy through wind, water, or solar. So kanina, example na natin yung through wind, which is our windmill sa Ilocos, ayun yung great example. Through water, which is Pagsanhan Falls, which is yung falls doon nakagawa ng energy, and then solar, which is the sun, and then yung sa LTO kasi nga merong solar panel doon, is makakatulong sa atin sa paggawa ng energy. So alam kong medyo relate na tayo dito kasi napag-aralan naman natin doon simula elementary to high school, which is mas binibigyan na natin na idea yung matatopic pa natin sa free vibration. So kung bakit binalikan din natin yung ganitong topic, no? So pagkatapos nun is free vibration ay vibration engineering ulit. So free vibration we always found in any surrounding. So bakit nga ba nasabi na bakit nga ba naman sabi na nahanap natin to sa any surroundings. So nahanap natin sa any surroundings kasi nga through wind, water, or solar. So, di ba, kahit saan naman tayo pumunta, merong hangin, saan naman tayo pumunta, merong tubig, saan naman tayo pumunta, merong solar. Yung water, hindi siya pwede sa lahat kasi may mga country na medyo kawalan sa tubig, which is yung Africa, ganun yung mga nasa Africa countries, medyo sila sa tubig. So, parang hindi sa kanila pwede yung water energy, which is yung sa mga falls, ganun. Ang pwede sa kanila is solar kasi mainit sa kanila. So, pwede yun, no? So, pwede yung gamitin. So, any surroundings, no? Sa lahat, pwede tayong gumawa ng renewable energy, which is yung basta meron capable yung lugar natin sa pwedeng pwedeng pagkuhaan ng energy, which is yung yung tatlo na pwedeng pagkuhaan ng energy, which is yung wind, water, or solar. So, any surroundings, no? So, hindi lang naman din yung example na sinasabi ko sa tatlong yan, to the wind. Meron din tayong, sa next slide, makikita din natin yung dalawang example ko. Pero hindi pa to yun. So, dalawang example lang inilagay ko. So, next slide tayo. So next slide, vibration occur in almost any sector of engineering. So sa engineering, no, makikita natin yung free vibration is makikita natin halos sa part ng ating engineering program, no. So di lang sa program, kahit sa field makikita na natin to. Hindi ko pa experience na, pero sa sinasabi ng ano natin, syempre wala pa tayo doon sa part na nasa part pa tayo na mahirapan pa tayo sa mga sa mga subjects natin. So ito siguro experience na to ng mga engineer natin na mga kilala. So vibration can occur in almost sector of engineering. So it easily adapted to different scenarios by simply changing the notation. So ano nga ba yung dalawang uri na nilagay natin dito sa ating PPT, no. So meron ditong mechanical vibration, no, which is pinaka magandang example kasi syempre mechanical engineering yung tinitake natin, no. So ito yung kinuha ko na isang example. So ano nga ba yung mechanical vibration? So the measurement of periodic process of oscillations with respect to an equilibrium point, such as the vibrating mechanic, which is makikita natin sa mga example dito is yung sa mga example dito yung mga beams, strings, plates, and membranes. So ayun, so yung mga beams, no, so medyo familiar tayo sa beams since meron naman tayong so yung sa una nga yung sinasabi natin din yung non-standard boundary, which is yung may solving tayo, which is differential equation and integral. No, so ayun nga, so hindi lang naman yun dun tayo magfo-focus sa solar energy, no, meron din tayong solving dito. So ayun na nga, so yung beam, strings, and plates, ang familiar tayo dyan sa subject natin na rigid body, so narinig naman natin na yun. So may mga solving din dyan, no. So ayun, so ang pangalawa is yung what is speed vibration. So ano nga ba yung speed vibration? So ang speed vibration are units of meters per second. This is how acceleration measure how quickly speed changes with time. So medyo familiar din tayo dito, no, kasi meron naman tayong equation dito na sinosolve kung paano makuha yung speed, di ba? So ayun nga, medyo medyo nag-recap lang tayo ng konti kasi mas lalalim tayo sa next topic natin. So parang introduction lang to talaga ng free vibration. So hindi pa to yung pinaka ito yung pinaka topic, pero hindi pa to yung pinaka deep ng aming presentation. So may mas malalim pa diyan. So ayun, so medyo familiar na tayo sa sa mga discussion. Medyo familiar na tayo sa mga sinabi ko. So medyo lalalim na tayo ngayon sa PPT natin, no. So ang next na i-report natin is all about viscous damp. So ayun, so sa lahat na nakikinig, thank you. Kung may tanong man kayo, pwede kayo mag-comment sa YouTube channel na gagawin namin, or pwede kayo mag-PM sa amin para mas ma-enlighten namin, or kung may mali man kaming nasabi, at least tatanggapin namin 'yun kasi mas gusto namin yung may natututunan kami sa aming pagkakamali. So ayun lang, maraming salamat sa pakikinig. Ako nga pala ang unang reporter na si Peter John A. Galientes. So ayun, maraming salamat sa pakikinig. Sir, thank you. Thank you po.
Now, after we discuss the free vibration, now let's proceed to the next topic, which is the viscous damping. So, what is viscous damping? Viscous damping is damping that is proportional to the velocity of the system. So, it means that the presence of frictional forces in the structure which transform the mechanical energy of system into other forms of energy such as heat. So if damping is completely absent, In an ideal system, a structure once excited will oscillate indefinitely with constant amplitude at its natural frequency. So, like for example, a viscous damper model considered damping behavior to be similar to a piston moving a viscous fluid. The viscous damping forces produced are proportional to the velocity of the piston. However, the actual damping in a structure may result from looseness of joints, dry friction between components, um, material damping, structural damping, and many other complex causes that would lead to nonlinear behavior of the structure. So, now let's proceed to the equation for damp. So we will only consider linear viscous dampers. That's where the damping force is linearly proportional to velocity. So the equation for the force or moment produced by the damper in either x or theta is um, F sub c is equals to c times x. So and then m sub c is equals to c times theta. So as you can see, to determine the equation of motion, we draw a free body diagram of system with perturbation and apply second law of Newton's second law. So as we can see, the free body diagram, now we can derive the following given. So with the mass m, the constant is k, and the damping constant. So if we derive net force sub x is equals to mass sub x is equals to mass times x, and then minus f sub x minus f sub c is equals to m times x, and then minus k sub x minus c times x is equals to m times x. Then the final is m times x plus c times x plus k times x is equals to 0. So after that, the solution of the differential equation yields the crucial damping statement. So the following is the solution to system differential equation, and that's it.
So, this part naman ay magbibigay sa inyo ng different solution about sa damping statement. Here are the following solution to the different system equation. As you can see, A is always the constant, while the values of R can be obtained by differentiating this general form of the solution and substituting into the equation of motion. So, bawat solution ginagamitan ng pag-derive or differentiating para makuha yung equation na hinahanap. The damping ratio can be used into 4 different ways. Number 1, undamped or C is equal to 0. Undamped system oscillate about the equilibrium position continuously unless some other force is applied. So, as you can see in the figure, para siyang wavelength na naka-zigzag doon sa plane, Cartesian plane. Ganyan yung itsura ng undamped. Next is overdamped, or C squared is equal to 4mk. Roots are both real and negative, but not equal to each other. overdamp system moves slowly towards equilibrium without oscillating. Ganyan yung itsura niya sa figure, overdamp. Kung paano siya mag-response ng wave ng paggalaw niya. Ah, andito, makikita niyo yung solution for overdamp system. And, andito, makikita niyo yung solution for overdamp system. And, makikita niyo dyan sa slide na to. This is the critical damp, or C squared is equal to MK is equal to C to, basta ganyan, hirap basahin. Roots are real and both equal to negative mu n. Critically damped systems will allow to fastest return to equilibrium without oscillation. So parang katulad lang siya ng overdamp yung itsura niya. Walang anong pinagkaiba. Kumbaga parang mas mabilis lang yung allow ng equilibrium, yung paggalaw niya kaysa dun sa nauna.
The solution for a critically damped system is x times t is equals to a plus bt times e raised to w sub nt, where a is equals to x sub 0 and b is equals to b sub 0 plus x sub 0 times w sub n. Damp. Complex numbers make up the roots. Systems that are underdamped oscillate around the equilibrium point. Unlike undamped systems, the amplitude of the oscillations decreases until the system reaches equilibrium and stop moving. Pag sinabi nating oscillator or oscillations, ito yung pattern na nagbabalik sa original state or sa kung saan siya nagsimula after many generation of finite numbers na dumaan sa kanya. Sinasabi ditong underdamped system, ito yung condition in which damping of an oscillator causes it to return to equilibrium with the amplitude gradually decreasing to zero. System returns to equilibrium faster, but overshoots and crosses the equilibrium position one or more times. The solution for an underdamped system is x times t is equals to c sub 1 sine omega dt plus c2 cosine omega dt times e raised to omega sub n zeta t, where c1 is equals to v sub 0 plus omega sub n zeta x sub 0 over omega d. C2 is equals to x sub 0 or zeta is equals to c over 2m mega sub n. This can alternately be expressed as x times t is equals to a sine omega dt plus theta times e raised to omega n zeta t, where a is equals to the square root of v sub 0 plus omega n zeta x sub 0 squared plus x sub 0 omega d squared over omega squared sub d. Theta is equals to tan negative 1 raised to negative 1 times x sub 0 omega sub d over v sub 0 plus omega n zeta x sub 0. Zeta is equals to c over 2m omega sub n. Omega sub d is called the damped natural frequency of the system. It is always less than omega sub n. Omega sub d is equals to square root of 1 minus zeta squared times omega sub n. The period of the underdamped response differ from the undamped response as well. Undamped is equals to tau sub n and equals to 2 pi over omega sub n. Underdamped is equals to tau sub t or equal to 2 pi over omega sub d.
So, my topic is all about design consideration. So, pag sinabing design consideration, nandyan dapat yung concepts, drawings, dimensions, at materials. So, dapat meron kang analytical skills, planning, focus, and strategies. Dahil naglalaman ito ng mga problem solving kung saan yung equation at graphs ay present. Dahil dito kinakailangan analyzation at kung paano mo ito bibigyan linaw o ma-recognize. So, let's figure it out. So, next is, what is vibration design consideration? These are the areas that may affect the requirements, design, or operational concept of a system. Vibration is a phenomenon which exists and presents itself in many ways, such as heartbeats, car trouble, or earthquakes, to name a few. So, pag sinabing vibration, ito yung bagay na kung saan nagkakaroon ng mga sounds or paggalaw na tinatawag na periodic motion or oscillation sa isang object tulad na lang ng sa cellphone, sa train, sa pagsakay mo sa barko, o sa pagandar ng mga machines or sa heartbeat natin. May nabubuo nagbibigay vibration dito. So, next is ground vibration. So, pag sinabing ground vibration, are composed of a surface wave, R wave, a S wave, and a P wave. So, these are the three types of waves. First is R wave or tinatawag na Rayleigh wave. Second is S wave or tinatawag na shear wave. Then last is P wave or tinatawag na compression wave. So, first is the Rayleigh wave. So, pag sinabing Rayleigh wave, ito yung earthquake na may violent shaking ng isang rock below the surface ng Earth. So, sinabing Rayleigh wave, ito yung nagka-travel sa near surface ng solids, kung saan nag-include siya both longitudinal and transverse motion na nagde-decrease exponentially sa amplitude na may distance surface kung saan nag-increase. So, yung existence naman ng Rayleigh waves, na-predict naman ito ni Lord Rayleigh ng 1885. Kaya pinangalanan to na Rayleigh wave kasi ay binase niya to sa kanyang pangalan. So next is S waves o tinatawag na secondary waves or shear waves. Minsan tinatawag na elastic S waves dahil kaya nito tumulay sa body ng isang object, hindi tulad sa surface waves. So, itong S wave ay transverse waves. Ibig sabihin, yung direction ng particle motion ng S wave ay perpendicular papunta sa direction ng wave ng propagation, at kung saan yung pinaka main restoring force nito ay nanggagaling sa shear stress. So, pinangalan nitong secondary wave dahil nagmula ito sa second type na na-detect ng seismograph pagtapos ng compressional primary wave or P wave. Dahil yung S wave kaya mag-travel ng mabagal sa mga solids, hindi tulad sa P waves. Kasi yung S wave hindi maka-travel papunta sa molten outer core ng ating mundo. Kaya nadudulit ito ng shadow zone kung saan kabaliktaran nito ng kanilang origin. Pag tumama itong S wave sa isang boundary na pa-oblique angle siya, ito ay makaka-create ng P waves sa propagate papunta sa liquid medium nito. So, ayun yung ibig sabihin ng S waves. So, pinaka huli naman ay yung P waves or tinatawag na compressional waves. Itong P waves kaya mag-travel ng mabilis at nangunguna mag-arrive sa isang earthquake. Pag sa S waves, 'di ba, generally kaya mag-travel ng mga 60% ng bilis sa P waves. At sa S wave, palagi nag-a-arrive pagkatapos ng P wave. For example, yung mga sound waves, tinatawag ito na P waves na may high natin na frequency para marinig ng tenga natin. Hindi tulad sa S-wave na parang siyang wiggling o pasigsag yung motion niya. So, ayun yung pagkakaiba ng R-wave o tinatawag na relay wave. Second is S-wave o tinatawag na shear wave. Then yung last is P-wave na tinatawag na compression wave. So, makikita naman dito sa mga pictures na nakalagay dito sa PowerPoint yung pagkakaiba ng R-wave, S-wave, and P-wave. At doon lang natatapos ang aking report. That's all. Thank you.
So now we proceed to the piping vibration design. There are two types of design in piping vibration, which is the static and the dynamic. But first, we introduce to you the static design. So what is static design? Static design involves the thermal effect on the piping system, so that their designs are focusing or simply more on pressure, weight, and other applicable loads. So there are many ways or areas need to follow or to consider or approach your service. But first, we need to be more precise in visualizing or accurate assumption in the piping models we are about to do. So the next is the vibration and thermal stress are taken into account. So what is that? It simply says that you need to consider the every design and part of the pipes windward and consider where have to be used of. Since we are pertains to the thermal loads, it seems the need to be to design its compatibility. Then next one is when it pertains to specialty restraint and pipe clamps, that it needs it helps that ineffective design for the satisfaction of the vibration for them to secure every path throughout design aspect. So for the last pointer, it is the ability. Simply says in that slide that its ability or their ability to support other design requirements such as the bird pipe, glass, reinforced epoxy, and flexible pipe. So now let's proceed to the dynamic design. Compared to the static design, it focuses on the causes of motion and the changes in motion as known as dynamics. So the pointers or the areas considered include the pressure, pulsation, and vibration affecting the piping near the reciprocating compressor and pumps. So what is that? That let's consider the pressure pulsation in the piping design, that it affects more on compressor and pump. So last not the least is the dynamic simulation and assessment of centrifugal compressor, surge control, etc. So what is that? So it means that in simulation and evaluation, we're going to consider the centrifugal compressor, or as known as the radial compressor. It is the work absorbing turbo machine that achieves a pressure rise by adding the kinetic energy or the velocity to a continuous flow of fluid through the rotor or impeller. It has the high demand of the compressed air, so piping design should adjust. So since we all know that as the pressure increases due to the compression of the pipe, thickness increases, which increases the rigidity of the connected pipe, and automatically the loads at the nozzle increase. Thank you.
Harmonic motion. Let's know more. motion is a regular vibration in which the acceleration of the vibrating object. Simple harmonic motion is a sort of periodic motion in which the moving object restoring force is zero. For harmonic motion, the relationship between displacement and time can be stated as the following notation is used in SHM. X is equal to this displacement and A for acceleration, T for period, W is for angular frequency, F for frequency. X is equal to X sub 0 sine times WT. W means angular frequency and T per period. X sub 0 it's also known as the omega. Another measure of frequency is the circular frequency. W measured in radians per seconds. F is equal to 1 over T, where F is frequency hertz, T is time completed in 1 cycle in seconds.
The first derivative of displacement with respect to time is defined as velocity. The displacement equation for a harmonic motion is x is equals to x sub 0 sine multiplied to wt. W means omega or angular frequency. X sub 0 can be also written as A for acceleration. The equation for velocity is given by the first derivative of this equation. X equals to W or omega multiplied to x sub 0 or A multiplied to cosine and multiplied to W times time. This is the free body diagram of simple harmonic motion. Types of harmonic motion. Harmonic oscillator in physics. In classical mechanics, a harmonic oscillator is a system that, when displaced from its equilibrium position, experiences a restoring force F proportional to the displacement x, written as F equals to negative k times x. Kepler's law of planetary motion. In astronomy, Kepler's law of planetary motion, published by Johannes Kepler between 1609 and 1619, describe the orbits of planets around the Sun. Quasi-harmonic motion. The quasi-harmonic motion, or the quasi-harmonic approximation, is a Fanon-based model of solid-state physics used to describe volume-dependent thermal effects such as the thermal expansion. It is based on the assumption that the approximation holds for every value of the lattice constants, which is to be viewed as an adjustable parameter. Musical universalis, or the music of the spheres. Chord progression or harmonic progression. In a musical composition, a chord progression or harmonic progression is a succession of chords. Chord progressions are the foundation of harmony in Western musical tradition from the common practice era of.
Now let us tackle stability. First, we need to define what is stability. Stability refers to a structure's resistance to unwanted movements such as sliding, collapsing, and overturning. When we say sliding, ito yung instance na nagmo-move yung structure either left or right due to geographical phenomena like earthquake. Collapsing and overturning happens when structural components such as beams, columns, and the foundation is compromised. Yung sinasabing foundation dito is ito yung ground na kinatatayuan mismo ng isang infrastructure. So, pag sinabi naman natin compromise, ibig sabihin hindi maayos at hindi matibay yung pagkakagawa ng mga components na ito. Pag nangyari naman yung sliding, collapsing, and overturning, it means na unstable yung isang infrastructure or unstable yung mismong ground na kinatatayuan. So, there are also two causes of structural instability. First is yung large deformations of the structure. So, yung large deformation of the structure, hindi maiiwasan to, especially if matagal nang nakatayo ang isang infrastructure. Dahil matagal na nga siyang nakatayo, ibig sabihin, nag-degrade na yung quality of materials na ginamit sa pagbibuild sa kanya. So, for example, nagkaroon ng earthquake, dahil nga degraded na yung quality ng materials, hindi maiiwasan yung large deformation ng structure, which also causes structural instability. The second cause of structural instability is yung inelasticity of the structural materials. So pag sinabi nating inelasticity, ito yung inability ng material to retain its original form or shape after the removal of the applied force. So yung one component na tinitingnan sa pagbibuild ng isang infrastructure is yung elasticity of materials, which is yung ability niya nga to retain its original shape or form after the applied force is removed. So those are the two additional causes of structural instability. Hindi lang yung sa compromised yung foundation compromised yung kinatatayuan ng structure. So sa part na to, tinatakil natin yung structural stability. Punta naman tayo sa mechanical stability. So, sa mechanical stability, may tinatawag tayong stability task force. So, yung work ng stability task force is it covers a lot of ground in mechanical stability. So, ano nga ba yung ground na kinakover niya? Ito yung vibration management for assuring product quality. Paano nila na-assure yung product quality and mechanical stability? So, there are four main methods. The first one is yung calculating vibration tolerances and monitoring. Sa part na to, there are three major parameters to measure vibration. First is yung acceleration, velocity, and displacement. So, yung three parameters na to, ina-analyze to ng stability task force para ma-diagnose yung issue and to prepare countermeasures para hindi na lumala. Then the second and third one is reducing sensitivity to vibration and vibration isolating of sources. So yung dalawang to, ito yung ways on how to reduce sensitivity to vibration. So ang ginagawa ng stability task force is they mechanically isolate vibrating source or surface to reduce exposure. Then the fourth one is yung active systems. So then let's proceed to ways to consider. So ito yung mga ways na kino-consider ng stability task force to to reduce sensitivity to vibration, or yung ito yung way nila on diagnosing the issues regarding vibration. So the first is yung optical components. So yung optical components, ito yung in beam lines and magnets and accelerators must be well aligned to each other. This means na we need to make sure na yung mga materials that are supposed to be connected and aligned are properly aligned to ensure stability. The second one is vibration isolation. So parang inulit lang yung main methods ng stability task force. So vibration isolation often involves putting things on very weak springs or supports. So yung vibration yung tinatakil niya na vibration isolation dito is like an experiment or test para makita kung saang part ng structure yung sensitive sa vibration, and to prepare countermeasures na rin for this problem para hindi na siya lalong lumala. And that is all for stability.